Hello, in this video we are going to go over an exam question from a couple of years ago. We have a quadratic function given on factorized form and it has a parameter. So the function is given by y equals x minus p in one bracket times x plus 2 in the other bracket. And we are also given the information that p is greater than 2. Now, like all questions where we are given a quadratic function in factorized form, we do not wish to expand this and to obtain the standard form. Factorized form is actually super nice to work with, so we're going to keep it as it is. The first part of the question asks us to decide if the parabola has positive or negative concavity. To determine that, we need to look at the coefficient, the main coefficient. We usually call it a. That will be multiplying x squared if you were to expand this, but we do not need to expand it. And we can see that that coefficient is in this case 1, so the parabola has positive concavity. So keep in mind how the shape of this parabola is going to be like. Then we want to find the coordinates of the y-intercept of the graph. So we want to know what is the value that the function takes when x is 0. So we are substituting the value of x by 0. So we are going to have minus p multiplying 2. So that's minus 2p. So the coordinates, because the question asks for the coordinates of the point where the y-intersection of the graph happens, are 0, minus 2p. We then want to find the coordinates of the x-intercept of the graph. And to do that, we want to know when the function takes the value 0. So we are going to apply the null factor law to say that that happens either when x minus p is equal to 0 or x plus 2 is equal to 0. Those are the two options we have. So the first option will be when x is equal to p, so that will be the point with coordinates p 0. And the second case will be when x is equal to negative 2, so that will be the point with coordinates negative 2, 0. So I'm going to quickly make some axes over here. I am going to start adding the information I have so far. Well, I'm going to set the negative 2 over here. And we know that, well, then in this side we have 2. And then we know that p is a number that is greater than 2. We don't know how much bigger it is. Doesn't really matter. I'm just going to put my p here. So I'm going to add the points I know so far. I know that here when the x is negative 2, we have one of the x-intercepts. And when x is equal to p, we have the other one of the x-intercepts. And then I'm going to also add the y-coordinate of the y-intercept. So if I say that p is here with 3 squares, okay, I'm going to need to make my picture a little bit bigger, but then I'm going to have the y-intercept over here at minus 2p. I don't really know the value of p. That's not relevant. This is just the shape that the parabola is going to have, no matter what the value of p is. So let me just expand my axis a little bit over here. And we have over there the y-intercept. So these are the pieces of information that we have so far. We also want to write down the equation of the axis of symmetry. So we want to know what is halfway between the two x-intercepts. So the equation is going to give you given by taking the average of the x-coordinates of the x-intercept. So p plus minus 2 divided by 2, that is p minus 2 over 2. And notice that this value has to be greater than 0 because in the numerator we have p minus 2, which has to be greater than 0 because p is greater than 2. And then we divide by 2, so that keeps our number positive. So this number over here is greater than 0. So I'm going to add the axis of symmetry to my picture. somewhere around here. I just know it's in the positive side and it has to be halfway between what I mark as the p and the value of -2. So there it is. This is x equals p minus 2 over 2, and this is the axis of symmetry. Okay, I made a little bit of space because we needed for answering part E. We want now to explain why the vertex of the parabola belongs to the fourth quadrant. I mean, we could find the coordinates of the vertex and show that the x-coordinate is positive and the y-coordinate is negative. I'm just going to try to explain this with the information we have so far. That's going to be enough. So first of all, for the x-coordinate of the vertex, we already found that because we already found the equation of the axis of symmetry. So this is p minus 2 over 2, which is greater than 0. So that means that the vertex is going to be either in the first or the second quadrant. Sorry, the first of the fourth quadrant. Now, for the y-coordinate, let's see what we know. For the y-coordinate of the vertex, my claim is that this is less than the y-coordinate of the y-intercept. Okay, why is this? First of all, the vertex of this parabola, because it's a parabola with positive concavity, is going to be a minimum. So it has to be for sure less or equal than the y-coordinate of the y-intercept. But it can't be equal because we already know that the vertex is not the y-intercept, because we know that the vertex is in the axis of symmetry, which is not the y-axis. So then that means that the y-coordinate of the vertex has to be strictly less than the y-coordinate of the y-intercept, which is a negative number. So that means that the vertex has two coordinates. Well, the first one we can write it, the x-coordinate. That one is greater than 0. And then the y-coordinate, we don't know it, but we know that it's negative. So this means that this belongs to the fourth quadrant, because those are the points that are in the fourth quadrant: positive x-coordinate, negative y-coordinate. So with the information that we have so far, we have to sketch the graph of the function. So I'm going to add an auxiliary point that also has coordinates, y-coordinate minus 2p. It's going to be here, just symmetric with respect to the axis of symmetry. And then I'm just going to do my best to sketch this as nice as possible. Okay, this is a sketch. I mean, it's not perfect, but let me go over what are the things that you want to make sure that you draw nicely on a sketch. You want to make sure that if you're sketching a parabola, it looks like a parabola. So it looks rounded at the vertex. Yeah, here there's a point, kind of nice, smooth minimum. You want to make sure that that's the case. You don't want sharp ends at the vertex. I also want to make sure that the branches are symmetric with respect to the axis of symmetry. And this looks reasonably symmetric. And then I want to make sure that the branches are infinite, so I need to make them as tall as the axes are. So that's why I end them, the negative one here and the positive one here. You can add an arrow implying that this goes to infinity. That's also fine. I have the axis of symmetry in my picture. It's labeled, and I also wrote the equation. I marked the two x-intercepts. I wrote that there are x-intercepts, and I wrote what their coordinates are. I just wrote the -2, but that's enough because it's in the x-axis. I wrote the y-intercept is the y-intercept, and I wrote what the y-coordinate is. And then I marked the vertex, but I don't know the coordinates yet. I could write the one that I know so far. Now we are gonna need to find the y-coordinate of the vertex for the next part, because we want to find for which value of p the y-coordinate of the vertex is going to be negative 16. So I'm going to find what is in general the y-coordinate of the vertex, and then I'm going to equal it to negative 16, and I'm going to find which value of p makes that true. So let's do it. To find the y-coordinate of the vertex, I need to evaluate our function y at the x-coordinate of the vertex, so at p minus 2 over 2. So I'm going to substitute the value of x by that value, so I'm going to have p minus 2 over 2 minus p in the first bracket, and then that times p minus 2 over 2 plus 2 on the second bracket. Inside each bracket, I'm going to take common denominators so I can sum the terms that they have. So I'm going to have, for a common denominator 2 in the first bracket, I'm going to have p minus 2 minus 2p, so I had to multiply p by 2 for the common denominator. And then in the second one, I'm going to have p minus 2 plus 4. I need to multiply 2 by 2 and 2 for the denominator. So this is equal to, let's see what we have inside each bracket. We have p minus 2p minus 2, so that's minus p minus 2 over 2 times p plus 2 over 2. Now notice that the first bracket, if you take negative 1 as common factor, then it's just p plus 2. So we have two factors p plus 2. I'm going to write that square, and then divided by 2 squares, so 4 for the denominator. And here we can see that this is a negative number because we have something positive p plus 2 square over 4 multiplied by negative 1. So this was another way of checking that the vertex is on the negative side, on the fourth quadrant. But that's not what I want to do right now. Right now I want to solve for p when negative 1 multiplied by p plus 2 square over 4, so the y-coordinate of the vertex, is equal to negative 16. I'm going to divide by 1 both sides to begin with. So I'm trying to see when p plus 2 square divided by 4 is equal to 16. So if I multiply by 4 both sides, the condition that I have is that p plus 2 square has to be equal to 16 times 4, and that 16 times 2 is 32 times 4 is 64. So that means that p plus 2 has to be equal to either plus or minus 8, because that's the square root of 64. So we have two options. One option will be that we consider the positive sign, so p plus 2 is equal to 8, and that would mean that p is equal to 6. And that's a possible solution because this number is greater than 2, so this is good for us. The other option will be that p plus 2 is equal to negative 8, so that would mean that p is equal to negative 10, but that's impossible. We don't want that because we know that p is greater than 2. So the only solution that we found for the value of p was p equals to 6.